pretty much applies to everything that we're going to do in math, period. You can only add and subtract when things are alike. You can multiply and divide anytime. Even back when we were doing fractions, you could add and subtract only when the bottoms were alike. You can multiply and divide anything. So let's start out applying this to algebraic expressions. The three out front, these numbers are called coefficients. It tells you how many of something you have. So this is a positive 3x and a positive 5x. Those are alike, so we can combine them. That gives you 8x's. Notice the x does not change. The positive 4 and the negative 3 combines and gives you a positive 1. Make sure you put plus or minus in front. Even that 8x, you can imagine it being a positive 8x. The next one, you have an x squared and a negative 3x squared. Anytime there's no number in front of it, understood to be a 1. So 1x squared minus 3x squared is negative 2x squared. So again, notice the x's do not change. The 6x combines with 2x and gives you a positive 8x. The minus 1 is by itself and has no like terms, so it stays by itself, minus 1. Now, if you're adding, subtracting radicals, again, they have to be the same before you can add or subtract them. So what we're going to do to make these the same possibly is we're going to simplify the radicals. The square root of 20 is the square root of 4 times 5, which is 2 root 5. The square root of 45 is the square root of 9 times 5, which is 3 root 5. And again, notice what I said. Treat it just like x's. 2 root 5s, 3 root 5s, a total is 5 root 5s. Notice just like the x's, the root 5s stay the same. Next up, the square root of 27 minus the square root of 18. They're not alike, so we can't add them right now, but we can see if we can make them alike. So the square root of 27 is 9 times 3, which is 3 root 3. Square root of 18 is the square root of 9 times 2, which is 3 root 2. So in this case, since you have a 3 root 3 and a 3 root 2, since these are not alike, they cannot combine. The coefficients out front tell you how many there are of them, but if they're not alike, they will not combine. The next one, the same thing applies to scientific notation. The 2.3 and the 3.1 are your coefficients. They tell you how many 10 to the fourth you have. Since both of these are 10 to the fourth, you can combine them. 2.3 and 3.1 gives you a 5.4. And again, just like the x's, just like the roots, the 10 to the fourth stays the same. Now, sometimes you might have to change scientific notation to make them alike. Notice you have 5.6 times 10 to the eighth. And what we can do is we can change the second one. 3.7 times 10 to the seventh means we've got to take this decimal and move it 7 times to the right. If we were to put it right here, we would now have to move it 8 times to the right. So if we move it to right there, we now have times 10 to the eighth. The coefficients out front is what's going to get subtracted. And I believe that gives you 5.22 times 10 to the eighth. We simply subtracted the coefficients. The 10 to the eighth stays the same. And that's how you combine like terms.